So the second type of sequences we're going to talk about are geometric sequences. And geometric sequences change by a different amount each time. You must multiply the same numbers with each term to get the next term. So we're going to change by a different amount each time. You must multiply the same number with each term to get the next term. When your numbers are getting larger from left to right, you can find the pattern by dividing the second term from the first term. So 6 divided by 2 would get you 3. So 2 times 3 will get us to 6. 6 times 3 would get us to 18. 18 times 3 would get us to 54, and 54 times 3 would get us to 162. Now, when we work backwards, we have to divide, because we always are multiplying and dividing when we're doing geometric sequences. So we don't have to divide the first term from the second term, because we're already going to be dividing anyway. So we need to figure out what we need to divide by when we have a larger number going to a smaller number to get our next term. So if we divide 100 divided by 20, we would get 5. So we need to divide by 5, so 100 divided by 5 would get us 20. 20 divided by 5 would get us 4. But when we have geometric sequences, we always want to be talking about multiplication. So we need to flip our number so that it would be multiplication. So instead of dividing by 5, we are actually saying we're multiplying by 1 over 5. And that's because, let's say we have 100, and we're multiplying by 1 over 5, we would have to do 100 times 1 would get us 100 over 5. And then we would divide. So 100 divided by 5 would equal 20. So it's the same thing. We just need to make sure we make it into a fraction so we can multiply it versus dividing. So down here we'll talk about it a little bit more. So the common ratio, the ratio of a term and the previous term in a geometric sequence. So common ratio means how we are changing each time. So in the geometric sequences, we can write the current term as a variable and then multiply by the pattern. So it says multiplying by 4. So our expression would be n times 4. So our number in our sequence times 4. Or we can also write this as 4n, because this means 4 times the number 2. Now if we're multiplying by 1/2, we're saying n times 1/2. We can also write it as n over 1/2, because n times 1 would be n over 2. Either one of those ways would be correct. Now we're going to do an example. So looking at the side, we have 256, 64, 16, 4, and 1. So we need to figure out the common ratio between them. So how are they multiplying, dividing, or what's happening? So we can figure this out by dividing 256 divided by 64 to get the common ratio. So we're dividing by 4 to get to 64. So 256 divided by 4 is 64. 64 divided by 4 gets us to 16. 16 divided by 4 gets us to 4. 4 divided by 4 gets us to 1. So we need to write the type of sequence this is, and it's geometric. In geometric sequences, you are multiplying or dividing, or you're multiplying by a fraction. So that's how we know if it's geometric. If it's arithmetic, you are adding or subtracting. So the pattern would be multiplying by 1/4, because we have to be in multiplication. We cannot be in division. So when we multiply this, we have to flip it from 4 to 1 over 4, so that we're able to multiply instead of divide. So our expression could be n times 1 over 4, or it could be n over 4, because n times 1 would just be n, and then we can divide. So what would the next term in the sequence be? So we need to do 1 divided by 4, so we could write it this way, or, and get 1/4. Or we can write it this way and do 1 over 4, and we get 1/4.